For a long time after its disclosure, Pluto was an undeniable planet, close by its grandiose kin like Earth and Saturn. Anyway, researchers downgraded it to a diminutive planet, as it didn't meet one of the standards for being a planet. Regardless of its downgrade, it has held the interest and research efforts of cosmologists and skywatchers. Now, NASA has delivered shocking pictures of Pluto, and everybody is in a territory of shock. Subsequent to seeing these amazing photos, they can provide significant understanding into the secrets of the dwarf planet. What secrets await discovery in NASA's pictures of Pluto? These wonderful pictures have provided new data on Pluto's intriguing arrangement and environmental factors. Join us as we explore the primary genuine pictures of Pluto. In 1930, an American astronomer named Clyde Tombaugh was working at the Lowell Observatory in Arizona. He was utilizing a 13-inch telescope, which was somewhat astounding for its day. Tombaugh wasn't gazing idly into the vast territory of space. Rather, he was on a mission to find a 10th planet. This non-existent planet was first proposed by Percival Lowell, a notable cosmologist who believed something was out there. Lowell found a few oddities in Uranus and Neptune's orbits and speculated that they were caused by another planet's gravitational force. Unfortunately, Lowell died before he could find out the truth about his speculation. However, Tombaugh continued where he left off. Tombaugh spent countless hours examining visual plates and, at a time, using a device known as a blink comparator. This instrument allowed him to switch quickly between two plates. If there was a planet on the plates, it would appear to jump back and forth. Then, one day, his diligent work paid off. He saw a minuscule dot moving against a background of fixed stars. That was Pluto. Tombaugh's discovery of Pluto was a groundbreaking event that captivated attention around the world. On March 13, 1930, the public was informed of this finding, which ushered in a new era of cosmology. Now, the newly discovered celestial body had to be named. That is when Venetia Burney, an English schoolgirl from Britain, came into the picture. She is renowned as the first to name the dwarf planet discovered by Clyde Tombaugh in 1930. She was 11 years old when she proposed the name Pluto after the Roman god of the underworld. It was fitting for a planet on the cold, remote edges of our solar system. Additionally, the name Pluto was a fitting tribute to Percival Lowell. If you look closely, you'll notice that the first two letters of Pluto are the initials of Percival Lowell, a fitting recognition for the one who originally proposed the existence of this mysterious 10th planet. Once shrouded in mystery, Pluto has fascinated researchers since its discovery. This distant celestial body is in our solar system's Kuiper belt, a region beyond Neptune's orbit where icy bodies and comets form. Pluto is about 3.6 billion miles from the Sun and 4.67 billion miles from Earth at its farthest point. Its small atmosphere primarily contains nitrogen, methane, and carbon monoxide, which expands and contracts as it orbits the Sun. It is about 1,400 miles wide, or around half the width of the United States. Pluto's 5 known moons are Charon, the largest, followed by Nix, Hydra, Kerberos, and Styx. If you're thinking the moon names sound familiar, you are not mistaken. Pluto's 5 moons are named after various mythological characters from Roman and Greek folklore. This moon system may have been formed by a collision between Pluto and other similarly sized bodies early in the history of the solar system. Charon, the largest of Pluto's moons, is about half the size of Pluto itself, making it the largest satellite relative to the planet it orbits in our solar system. It orbits Pluto at a distance of just 12,200 miles. For comparison, our moon is 20 times farther away from Earth than Charon is from Pluto. An interesting fact is that Pluto and Charon are often referred to as a double planet. Charon's orbit around Pluto takes 153 hours, the same time it takes Pluto to complete one rotation. This means Charon neither rises nor sets but hovers over the same spot on Pluto's surface. One side of Charon always faces Pluto, a state called tidal locking. Pluto's other 4 moons are much smaller, under 100 meters wide. They're also irregularly shaped, not spherical like Charon. Unlike many other moons in the solar system, these moons are not tidally locked to Pluto. They all rotate and do not keep the same face toward Pluto. Pluto's extreme distance from Earth has made it challenging to capture images of it. Surprisingly, The first photo of Pluto was taken before its official discovery in 1930. Astronomer Thomas Sharrois took the first picture at the Lowell Observatory in 1915 with a 9-inch telescope rented from Swarthmore College. Besides images, astronomers and researchers have developed other techniques and ideas for observing Pluto, both from afar and up close. In 1964, a man named Flandreau was working at the Jet Propulsion Laboratory, JPL. Flandreau is an American aerospace engineer and professor emeritus at the University of Tennessee Space Institute. Flandreau had an ambitious plan that seemed like something out of a sci-fi novel. He proposed a mission called the Grand Tour. Why grand, you might ask? Well, the mission required a spacecraft to explore all the outer planets of our solar system, including Pluto, which was far and mysterious. Exciting, right? This Grand Tour concept was only feasible due to a rare planetary alignment in the late 1970s. This alignment would allow a spacecraft to travel between planets using a technique known as gravity assist, like a giant pinball bouncing off the planets. However, as you might expect, such a large-scale project came at a high cost. Consequently, despite its glory and promise, the Grand Tour was not approved due to its significant expenses. However, the Voyager program, which began in 1977, took advantage of this rare planetary alignment. 2 Voyager probes embarked on their own grand tour of the outer solar system, visiting various planets. Unfortunately, they did not reach Pluto. In July 1978, Pluto's largest moon, Charon, was discovered by James W. Christie using the 61-inch astrometric reflector at the U.S. Naval Observatory Flagstaff Station in Arizona. Pluto appeared as a fuzzy blob in the center of the image, with Charon occupying the elongated segment. Christie analyzed the fuzzy mass and found that it was Pluto's large moon. Moving into the 1980s, Voyager 1 had a chance to visit Pluto after its close encounter with Saturn in 1980. NASA scientists and engineers considered using Saturn's gravity to launch Voyager 1 toward Pluto. It could have been the perfect opportunity to visit Pluto with a flyby as soon as the spring of 1986. However, science often involves difficult choices. Instead of aiming for Pluto, the team decided that a flyby of Titan, Saturn's largest moon, would be a more valuable scientific objective. Titan is unique in our solar system because it has a thick atmosphere and is thought to have pools of liquid methane and ethane on its surface. While this mission decision precluded a Pluto flyby, it opened the door to some remarkable Titan discoveries. However, Pluto remained unexplored, and several scientists were eager to learn more about it. In 1989, a group named Pluto Underground was formed, led by Alan Harsh and Fran Bagel. The group consisted of scientists and engineers who felt Pluto needed more attention. After many hours spent on letter-writing campaigns, their efforts bore fruit. In 1990, NASA took notice, and the engineers began conceptualizing. However, before they could proceed, they faced a significant hurdle. To study this mysterious world, they anticipated that Pluto's extended winter would cause the atmosphere to freeze and fall as snow. To address this, they needed to design a spacecraft that was lightweight, fast, and strong enough to reach Pluto's surface. That's when they came up with a brilliant idea: Pluto 350. The 350 referred to the spacecraft's weight in kilograms. The team wanted it to be lightweight, not too good or bad, so they could send it directly to Pluto. To reach Pluto, they relied on the Titan IV Centaur, a powerful rocket. In addition to spacecraft, other instruments have helped scientists study Pluto. For instance, the advent of the Hubble Space Telescope gave researchers a more detailed view of the Pluto system. The telescope's first picture of Pluto was captured in 1994, showing both Pluto and Charon. At the time, it was the sharpest image of Pluto ever taken. In 1996, just a couple of years later, the Hubble Space Telescope focused on Pluto to gain a detailed view of its surface. This photo, taken 66 years after Pluto's discovery, revealed more surface details than any other planet in the solar system, except Earth. The image paved the way for the New Horizons spacecraft mission in 2015. Before that, NASA initiated the New Frontiers program in 2001. The program's goal was straightforward: conduct medium-sized missions to uncover the secrets of different worlds. Their first exciting mission was the New Horizons mission, a spacecraft designed to explore Pluto, its moons, and the Kuiper Belt. Alan Harsh, a dedicated planetary scientist, led the charge. He was passionate about space exploration and couldn't wait to get started. However, he didn't do it alone. He collaborated with other skilled individuals from Johns Hopkins University, Southwest Research Institute, Ball Aerospace, and NASA's Goddard Space Flight Center. On January 19, 2006, something incredible happened.